All right. I'm now on the clock, so I'll get started. Hello, my name's Jamin Morrison. I'm here from Lacuna Space. We've got a lot to get through in this presentation. I'm just going to do, for those of you who are new to Lacuna Space, I'll do a recap, and I'm going to get into some of the news and applications that we're serving, and then finally I'm going to close on our network concept that we're pushing this year. So, what is Lacuna Space? We have a lone whisper technology, which is fundamentally a constellation of satellites that we've developed over the last 9 years to collect messages from devices such as this on the ground at very low power, and then connect those up to the satellite itself. So then the satellite system will then collect these packets from devices and then forward them through the complex hub into your application servers, where they're powering your graphs, your charts, your map visualizations, and your alarms. So that's the core of what we do. So this is our satellites themselves, just to help give a bit more context. Each generation has added new features and allowed them to have higher and higher throughput, so that we're now collecting 20 times more messages than we were with our first generation of satellites. And so to understand a bit more, we have terrestrial networks that work with cell towers. Devices then connect up to those and then forward those packets. Essentially, what we're doing with satellite IoT is we're not trying to replace these networks. The issue with these ones is that there's about 20 or 30% of area that don't get covered, the dead spots that exist in every single network. With satellite IoT, we're expanding the coverage, so working in sync with terrestrial networks to ensure that all devices can get connectivity anywhere in the world. And we've been very good at that. When we first started out, or when I joined about 7 years ago, we were building with a, fail fast. We'd watched Elon Musk rockets blow up on the launch pad a few times, and we're kind of excited to get into new space and learn from our mistakes. And so it was almost a little bit annoying when every single time they worked first time on orbit really, really well. We were really happy with the results that we saw, and the system took off. And that global spectrum scans we see there is actually the world's largest database for spectrum scan data for unlicensed spectrum. And see, unlicensed spectrum is great. It's a bit of a double-edged sword, though, because while you don't have to pass on expensive licensing costs for spectrum to your customers, it is a shared medium. And so that database of spectrum scans allows us to precisely work out how the spectrum is being used globally, so that we can ensure that our packets are getting transmitted at the right times in the right frequency band, where there's going to be the lowest noise and less chance of interference. And then finally, moving on to this section here, 4 million packets delivered. And that has been achieved using not maybe the chirp sped spectrum that you might be familiar with if you're familiar with LoRa, but using something called LR-FHSS. So this is a slightly different physical layer. It's still LoRaWAN, but it allows a much higher density of devices on the ground, allowing us to get to these kind of numbers in the short time span that we've been alive. So moving a bit more into our news now. So I'm excited to announce that this year in June, we've launched another 2 satellites to our ever-growing constellation, and we'll be launching 4 more by the end of this year. So that's 6 new satellites in this year alone. And you can see our little payloads just up here, on board a lovely rocket. Additionally to this news of the more satellites, we've also had the big ECC decision. So this is where all of the European regulators came together as a unified body of the continent in the great European way that it does, to agree that satellite IoT as a concept has again pushed through the next set of regulations. As IoT, the regulatory sphere is always ever-changing, ever-evolving landscape, but we're proud to say that Lacuna was one of the first ones on their list, as we've been working closely with them to push through that milestone. So next, I just wanted to touch a bit more on the applications that we serve. So we have a number of different verticals, from monitoring to metering for water meters and gas meters, and then out in the field where you're doing environmental quality. Lots of different applications, and then asset tracking on top of that, where you're monitoring buildings, power lines, and other assets. So I'm just going to go into a bit more detail on a couple of these. So this one is based in the UK, and it is in Wales. So the UK at the minute has a massive issue with nutrient pollution in the rivers. It's then devastating ecosystems along the rivers and also out at sea where these rivers flow. It's causing all sorts of issues with our biodiversity net gains targets and also building planning permission to be able to build new houses. So it's a massive blocker. So we've been working with the Welsh county councils there to develop a nutrient monitoring solution. So we work directly with them. This is Clifford from the Nutrient Management Board in Wales. We come in with him and we work with him to understand exactly what he is trying to monitor, what parameters he's trying to collect, and to select the correct sensors for the application. We then moved into the hardware integration stage, where we connect those sensors with one of our multi-node technology, allowing it to communicate in the lone WISPer sphere. Finally, then, we moved into the deployments. So this deployment that you can see here is in a valley location. At the bottom of a valley is where rivers typically flow, and this is like the kind of catch-all area for where terrestrial networks fail. Because in valleys, you often don't get connectivity from terrestrial networks. They had already tried both cellular and terrestrial LoRaWAN in this location and were unable to get connectivity. So we were really happy that they came to us. We worked with them and had a successful result. So this was the first prototype you saw going in. But since then, we've expanded out a number of sensors along the River Teifi to provide this full river monitoring solution, which is their dashboard with our data piped into it that allows them to make the important decisions about where the pollution's entering the river, what impact it's having, and what they can do to find out how to stop it and make actions on those. The next one I'm going to talk about is the black sigatoka banana disease, a little-known disease that actually potentially can devastate about 50% of the global banana supply. Now, I know what you're all thinking. Where am I going to get my potassium? Well, fear not. That's where we've come in. So we've partnered with Embrapa, who are the Brazilian environmental agency. So they have a large interest in ensuring banana production. We've also partnered with Aya Data, who provide world-class AI solutions. So they're getting all the data together, analyze it, generating AI models that allow people to make decisions. Also involved is the UK Agri-Tech Centre, and they help with the project management and tying it all together. So fundamentally, the solution is here, where we're connecting a leaf humidity and temperature sensor, again, to our multi-node technology, allowing it to monitor the conditions around the leaves where the fungus, which is black sigatoka, where it's attacking the leaves, and being able to understand those conditions and characterize the system. And so that in future, with just the sensors and the data you get from those alone, you're able to understand where the disease might attack, you understand where to use fungicides and how periodically, so unlocking those precision farming techniques. Also when you might want to cull your crop, and also when to harvest. We've also been working on a range of other projects as well. So we're working with Agorotech, who kindly joined us at the conference for a panel discussion later on today. They have really great soil sensors and also other weather stations. Lots of great technology there. We've also been working with Plant E, a traditional TTC comer. That's where we found them here. They've been deploying in peatland applications. So peatland restoration is a massive application that we see in the UK and also globally. Many others here, clear water sensors have really high precision nutrients. They monitor phosphorus and nitrates. Lots of other places that we're also dealing with these applications. I'm going to skip ahead now to our network concept. And so this is something that I'm actually really excited to present, because we've been developing this satellite constellation for the last 9 years, and we've harnessed all of this great technology. And it's tough because we've seen other people come in trying to do satellite IoT, and the list of growing satellite IoT providers who have failed and not made it and now gone out of business is growing. And we're keen to kind of correct that. And so instead of just making this technology and keep it to ourselves, we are opening the system. How it works is that we will supply you with our lone WISPer technology, including a satellite IoT payload. We will then help you fly that satellite, and it's a data sharing kind of framework where packets received from our devices to your satellite get forwarded to us, but also packets received on the rest of our constellation from your devices will then get forwarded onto you. So that's a key bit there, in that you no longer have to build an entire constellation yourself and wait to start delivering service till that constellation is enabled. You are already able, from the offset, to begin delivering your service. So that's a really key aspect there, to be able to deliver your service from day one. This enables you to have a lower upfront cost investment, and then additionally, you don't have to go through all of the rigmarole that we've gone through in the last 9 years to develop this. You don't have to reinvent the wheel. You can work with us. So it's a collaborative landscape, bringing down your time to market and also the time that you spend developing, really. Anyway, thank you very much. I've been Jamin Morrison. You've all been wonderful. I think we've got a bit of time for questions now, if there's any. Yeah, sure.
You said that the new satellites have 20 times higher output throughput than the old ones. Is it done by a larger coverage area, or how do you do that?
So the throughput of our satellites is done through refinements in how we're using the spectrum. As I've said, initially we started with using the LoRa chirp spread spectrum technology, which is the kind of the diagonal trace, if you've ever seen it on the waterfall graphs. But by changing over to using the LRFHSS, that new technology produced by Semtech, we're able to then deliver a higher resolution. And we've also been doing lots of refinements. So our gateway is actually a super sensitive LoRaWAN receiver, LoRaWAN gateway, in that, traditional, these devices, they only transmit at 25 milliwatts, which is tiny. It's almost the same power that I'm transmitting now through my mouth. And you're hearing that from 500 kilometers away in the sky. And these satellites moving at 7 kilometers an hour, 7 kilometers a second, sorry. So the sensitivity on these receivers is what we've been developing and really refining, the use of the frequency spectrum. Any other questions so far? Yes, please.
You mentioned you launched already 16 payloads.
We've launched 16 payloads, that's correct.
Does that correlate to worldwide coverage, or?
Yes, we have a global system. So that's, again, one of the benefits of a satellite system, is that a single satellite even can cover the globe. As you have your orbit of the satellite, and as the Earth rotates, it effectively scans the entire service. So you can provide a global service with a single satellite. What you do with the extra 16 that you launch is you increase the capacity to ensure that you can have as many different applications served at the same time. That's great. I think we have time for maybe a couple more questions. Please.
Flying your payload on my own satellite, what's the minimum requirements
So
for my satellite?
the minimum requirements for your satellites, we can help work with you to define those. We've obviously done it a number of times, and that's something we're looking to share. But in terms of the earnest on you to be actually build and operate, we're willing to help with that. What we're finding, though, is lots of the people taking up this sort of stuff are people like DS Telecom, OneWeb, and Omni Space. So these are already large parties, and they are looking to get involved in the satellite IoT. I mean, we're happy to help you work with you with a solutions provider. So there's a number of different solutions providers we've worked with: Open Cosmos, In-Space Missions, and Nano Avionics is the last one that comes to mind. And working with them, you're able to integrate your satellite payload into the rest of the satellite with all of its solar panels, power supply that you need, and get it operated. And so it's kind of working through those partnerships, and we're very experienced, and we're happy to help in that. But lots of people want to do it themselves. Any other questions? Please.
What's the typical round trip time from, maybe I missed it in the presentation, but from my device to my solution?
The round trip time. So it depends on the revisit time of the satellite. At the minute, we have a service that provides 4 contacts a day. And then the packets get transmitted from devices on the ground to the satellites. The satellites then carry those round to a ground station, hopefully at the poles, where it will get downlinked and then pushed out to the system. So the revisit time is 4 contacts a day. That then moves about 90 minutes or so, but we have about a 24-hour window where we're going to get those packets back to you. So allows those kind of applications that want their data, see their data flowing through the system and arriving at your dashboards, if that makes sense. So 24 hours from when it's transmitted back to you. One more question, maybe? Or we can close up there. Thank you very much. You've been wonderful.